If you have difficulty drawing inscribed circles and other complicated diagrams, know that you are allowed rulers and compasses on the exam. I also recommend that my students bring colored pencils. We have P is on this inscribed circle. Let's move it down a little bit. And we'll draw these distances to the sides, and we'll label these points X, Y, and Z. We'll make O be the center of our circle, and we'll draw some radii to the points where they're tangent at S and T, and we can draw OP as well. We'll note the distances from P to the three sides here, 9, 5, and 16. XZ is the height of our rhombus. That's 9 plus 16, or 25. This is also the diameter of our incircle, so our radius is 25 over 2. Let's take a look at this trapezoid XPOS, which I'll redraw here. We have right angles at X and S. I'm going to draw this other perpendicular to OS from P, and we'll call this point Q. OS is a radius of our circle, and so is OP. They're both 25 halves. PX is given in the problem statement. That's 9. We can find this distance OQ by subtracting 9 from 25 halves. Then we can find PQ using the Pythagorean theorem. And we find that PQ and XS are equal to 12. We can take a look at this other trapezoid, TYPO. We have right angles at T and Y. OP is a radius, and so is OT. I'm going to draw a perpendicular from P over to OT, and we'll call this point R. OR we get from subtracting TR from OT. TR is the same distance as YP. They're both 5. So this distance is 15 halves. We can use this to find YT, which is the same as PR, again using the Pythagorean theorem. Squaring and simplifying, this is equal to 100, so YT is equal to 10. Let's take a closer look at our circle and this point A that's tangent to the circle at points S and T. We have that the distance from A to S is the same as the distance from A to T. Let's call that distance Q. We'll add in P. We have that AX is equal to AS minus XS. We already found that XS is 12, so this expression is Q minus 12. And we have that AY is AT minus YT. And we found YT up here, that's 10, so this is Q minus 10. Now I'm going to draw AP, which is the hypotenuse of two right triangles. From right triangle APX, we have that PX is 9 and AX is Q minus 12. From right triangle APY, PY is 5 and AY is Q minus 10. We can set these equations equal to each other, expand, and solve for Q. So Q is equal to 25. Let's return to the diagram and draw another simplified version. Since we have AS now, all that's left is to find SD. But these two triangles are similar, triangle AOS and triangle ODS. We'll fill in these lengths and solve for DS. This means DS is equal to 25 over 4. Now we have a side length that's 25 plus 25 over 4, and our perimeter is just 4 times that. And our answer is 125. If you'd like me to solve any other contest problems, please leave them in the comments.